Yeah, hello everyone. Am I audible to all of you? Good evening to all of you. Yes, hi Joyanto. Hi, good evening. All right, so guys, I think you can see me, you can hear me. Everything is fine. So let's wait 1 more minute so that everyone can join and we can start with our session. Okay, guys, I think we can start. So let me share my screen. Fine. So, guys, as of now, I think we have discussed about the introduction of computer vision and we saw like the CNN discussion, right? Yes, hi, good evening, all of you. So we did the like CNN discussion there. I already showed you like how the CNN works, how it extract the features exactly. Okay, with the filters. So we saw one practical demo also. I think you remember, right? So first of all, let me write down today's agenda. What are the things we're gonna cover? So let me just write down here. Hmm. So today, the agenda would be. First of all, I will discuss about CNN. Okay, CNN overview, overview. Then second, we'll try to see padding and strides. Okay, padding and its strides in CNN. Then we'll discuss pooling layer. Okay, use of pooling layer in CNN. Okay, what is the use of pooling layer and why we use it? We'll try to see. Fine. And in the next lecture, we'll try to create our first CNN architecture. Texture, okay, with TensorFlow. Okay, TensorFlow Keras will use. So this is completely practical. So this part we'll try to understand tomorrow because this discussion will take time. Okay, first of all, we need to understand about the foundation, like how let's say we can create the CNN architecture, and for this, what are the components you required. Okay, everything we'll try to understand here. That means there is a concept called padding, stride, pooling. Okay, inside CNN. First of all, we'll try to understand. Try to see some visual example. Then we'll try to move on the practical implementation of it. Got it? Hmm. Can you read my message? Yes, Bivash, I can read your message. Uh, Good evening. I can see all of your messages. Okay, guys. So if you have any query, you can let me know. But first of all, I will suggest uh, try to stay with me. First of all, try to understand all the topics, then ask your query. So use PyTorch or to implement the CNN architecture. Yes, I will also show you the PyTorch implementation as well. Okay, Vishesh. No need to worry. Okay, both will try to explore TensorFlow as well as the PyTorch. Both will try to explore. But see, whenever you are using TensorFlow Keras, it would be easy for you to develop the architecture, okay, instead of using PyTorch. So those who have understanding on object-oriented programming inside Python, they can easily understand the PyTorch. But if you have the problem with the OP, so it might be a little bit difficult for you. Okay. But no issue. I will show you both of them. Now it's your choice which one you will be using. Okay. Yeah. See, you can, I mean, ask me anything. Okay. If you need anything from my side, just let me know. I'll, I mean, show you that part. I don't have any kinds of issue. Okay. So I'm here to teach you. So if you want to understand anything from my side, any kinds of topic, let me know. Okay. But first of all, let me complete. I mean, from my side, okay, whatever things are required to master the computer vision, then later on you can let me know, sir. Let's say this is the new framework, how to use it. Definitely, I can take one session or I can arrange a webinar on top of it. Okay, there is no issue from my side. Yeah, but I only need your dedication, guys. Okay, your dedication, your efforts, and your practice. Okay, so unless and until you are not putting your dedication, if you're not practicing, I can't do anything. As a mentor, I can only guide you, I can only show you the topics, but as a learner, you have to understand the concept, you have to practice, and you have to be a good developer at the end. Okay. Hmm. And through your journey, if you need anything from my side, feel free to let me know. Okay, I'll happy to help you with that. Yeah. See, I could have also recorded these are the video and posted over the, let's say, portal or YouTube, right? But why we are arranging these kinds of live session? Because always live session would be interactive. Even in the live session, I can give you more information. Sometimes some of the learner may feel boring, okay, joining the live session because it happens 1.5 hour, okay, or almost 2 hours someday, right? So 2 hours actually joining one session, it's a little bit hard for them. But if you join the session na, if you join the live session, you will be getting lots of information. So whatever information I know, okay, let's say whatever things I have learned in my career, I try to put everything in my session. Okay, it's not like that I'm skipping anything. Everything I'll try to share whatever I know. But it's not possible in the recording session. Okay, recording session, we just need to also take care about the time duration, so there is a possibility some of the topic may missed out. But in the live session, it's always okay. We can put the like lots of information, okay, whatever we know that. Do you have any Discord community something? No, I don't have any Discord community, but uh see, if anyone is interested, you can create a WhatsApp group and you can share in the chat. So I can also connect, you guys can also connect, okay, and then you can do the discussion. And apart from that, I have one WhatsApp channel, okay, if you want you can also connect there. So if you want to get the WhatsApp channel, so simply you just need to visit my YouTube channel. So here, okay, go to the community, and here maybe I already posted about the WhatsApp channel, not sure. Maybe I posted over my LinkedIn, just let me open. So in the post section, maybe it is available. See, I created one Telegram group, but the group has deleted automatically. I'm not sure why. So you can follow this channel, okay, as of now, this WhatsApp channel, to get all the update. I have shared the link in the chat. And if you want to create any, let's say, WhatsApp group, you can create and share the link, okay, to all of you. Fine. So yes, sir. So this was the agenda for today's discussion. So first of all, let's try to see the CNN overview. Yeah. Fine. So I already given you the introduction about the CNN, guys. I think you already know what is CNN exactly. So I don't need to explain, okay, about the introduction part. So first of all, let me give you some revision, okay, what we have learned exactly there. So let me take a image. See, guys, this is one image I have, and in the image, actually, you can see we are using convolutional neural network. Okay, you can see we are using convolutional neural network. So what happens in the convolutional neural networks, guys? Anybody can anybody tell me what happens? Or maybe I already explained, right? What happens in the conv layer? Let me know. What happens in the conv layer, guys? I already showed you one practical demo also, okay, with a Sobal filter. So those who have attended, please let me know. Feature map gets produced. Okay, yeah, feature maps. Yes, that means here we try to generate a features, right? Feature extraction. Yes, feature extraction. So let's say this is my image. Okay, this is my image I have. So first of all, what I have to do, I have to define an architecture. Now see, this is the architecture. So you can see this is my first layer of the architecture. This is the second layer of the architecture. This is the third layer, and so on. And at the end, what we have, guys, we have artificial neural network. Okay, because I already showed you how CNN architecture looks like. So at the very first time, we'll be using CNN. Okay, CNN architecture, and at the last, we'll be using ANN architecture. Okay, now at the first few layers, okay, what will happen, guys? It will extract words. For first few layers, what it will extract? Tell me. It will extract some edges. Yes or no? It will extract some edges. Edges means different shapes, whether it's a horizontal, vertical, rotated. Okay, these kinds of small shapes it will try to extract. I already showed you, right? I already showed you with the help of Sobal filter, right? Yeah, simple edges it will try to extract. Then whenever it will go to the middle layer, whenever it will go to the middle layer, what will happen? It will extract some more complex feature. Okay, complex features like this kinds of round feature, square feature. Okay, or let's say eye of the person. Okay, or let's say nose of the person, mouth of the person. This kinds of feature it will try to extract. Then in the last layer, what will happen? It will join everything, all the feature it will try to join, and it will try to create the complete, I mean, input you are giving. That means let's say this is the eye, this is the nose, this is the ear. Okay, then it will create some more complex feature. You can see it is creating the face, different face. Okay, based on that it is doing the classification, whether it's a Sarah's picture, whether it's a Bappi's picture, whether it's a, let's say, a Sai picture. Okay, so it will try to classify like that. Got it? So that's how actually your complete CNN works. Okay, that's how complete CNN works. So it has to do the feature extraction every time. And for this, what we use, guys, we use filters. Filters. Okay, what is the use of the filters? Filters is the it's a matrix. Okay, filter is nothing but it's a matrix. So with the help of this particular matrix, okay, we just try to perform the convolution operation. And how convolution happens? I think you remember one like this one. Let me show you. Yeah, filters. See, you can also call it as a kernel. There is two name. Either you can call filters, either you can call kernels. Okay, frankly. So someone will be calling as a filter, someone will be calling as a kernel. Okay, yeah. But filters, people will be using more. I've seen people use filters name a lot. Okay, instead of using the kernel. Yeah. So I think I shared you one visualization notebook, guys. I think you remember. So let me find that notebook and let me open it up. Mm, it is available here. This one, I think. So there I already showed you how convolution happens exactly. So there was a animation I showed. Yeah, Zovian.ai. Yeah, so there you will see the animation. Even I will show you another animation today. This will give you like more idea about the convolution. Okay. So let me go below. So see, guys, that's how convolution happens. Okay, so this is the filters you are using. Okay, this is the kernel you are using. So it will multiply with the image pixel and it will create the feature maps. Okay, every time. Even you can see the number calculation also. Okay, so let's try to understand this part in detail. Okay, how things are working. So for this, what I will do, let me use some other image. Just a minute. Mm, hmm. Okay, so let's say I have one image here. So guys, I think I already told you about the image. Okay, what image exactly? So image is nothing but at the end it's a pixel. Let me show you. So maybe you can see. So image is nothing but at the end it's a pixel. So let's say this is my image. So this is the handwritten digit image. So there 0 has been written. And if you zoom this particular image, you will see different pixel. Okay, you can see this is the pixel. Fine. And if it is a black color, that means sorry, if it is a white, that means there is a 0. Okay, there is a 0 value. And if it is dark, that means there are some numbers. Okay, Now you can see this is actually getting one shape here. Okay, and this is nothing but 0. So first of all, what we have to do, any kinds of image, first of all we have to convert it to the numbers. Okay, that means the pixel. And with the help of filters, okay, we'll try to do the convolution operation. This is the main idea inside computer vision. Fine. Now this is what your grayscale image. Now let's say this image is 28 cross, okay, 28 cross 28. Let's say with this 28 and height is 28. This is the image size. Let's say this is the image size, okay. And if you calculate this 28 28, okay, the number you will be getting, that many pixel value this image is having. And this is a grayscale image. And how many channel we have in the grayscale image? I think you know how many channel we have. We only have one channel, okay. And what about the RGB image, guys? So let me show you one demo of RGB image. uh, so this is the image of RGB image. Just a minute. Okay, so you can see this is the RGB image example. Hmm. Yeah. Now in the RGB image, you can see I have 3 channel. Just a minute. Hmm. So you can see in RGB image, I have 3 channel. We have red channel, we have green channel, and we have blue channel. Okay. And it consists of what? It consists of the RGB image at the end. Okay. Hmm. And RGB image can be any size. So most of the image actually you will see in the RGB, it is around 20 to 228 cross 228. Okay, multiply 3 because it is having 3 channel. So most of the, let's say, image size in computer vision, people use this particular size. Okay, this is the common size. Fine. And there is another size people use called 224 224 3. Okay, this is the size. Because see, if you see the model na, so if you open computer vision model, pre-trained model, so almost all the model supports this particular image size. You can see input shape of the image 224 224 comma 3. Okay, so during training actually they use this particular size to train the model. Okay, this image size they train use basically. So that's why this is the common size here. Okay, yeah. Now I think you remember, guys, we did the edge detection. Okay, that means uh, we use filter and we saw how it usually extract the features. Okay, that means we use something called Sobal filter. I think you remember, guys. We use Sobal filter. Let me write Sobal filters. Okay, Sobal filter we use. So Sobal filter is having two kinds of metrics. One matrix can extract the vertical edges. Okay, another matrix can extract horizontal. Okay, horizontal edges. Okay, now if you see, this is the image. Okay, original image. Now after applying this Sobal filter, okay, what it does, it extract this kinds of vertical edges. You can see. Okay, this is called vertical edges. Then after applying transpose of Sobal filter, okay, it has extracted the horizontal edges as well. And that's how this features looks like. So maybe I showed you one notebook demo, guys. Remember, 4 channel we have in the PNG image. Okay, Shashwat. And the number the last channel name is transparency. Hmm. So this is the transparency only. Okay, there is no, I mean, use of in the convolution, that PNG only. We'll be doing the convolution in RGB block. Okay, not in the transparency block. Yeah. So guys, remember till here, let me know. So we did the demo, remember, with the help of Sobal filter, we extracted the horizontal and vertical edges. That car example I showed you in the Jupyter notebook. Remember, all of you? Yeah. Okay. Now you can understand, right? You can understand how actually this image actually I'm getting, right? Yeah. Hmm. Fine. Now, I think you remember this was the example I showed you. So let me show you mathematically as well. So let's say this is my image matrix. You can see that's this is my image matrix. Okay. And here what we are using, we are using what we are using, guys. This is called filter. Now, can anybody tell me this filter, uh, what kinds of feature it can extract, horizontal or vertical? Can anybody tell me? The filters actually I'm using -1, -1, 0, 0, 1, 1. It will extract the vertical or horizontal. Any idea? Horizontal. Why? Because you can see this 0 is aligned with the horizontally, right? Hmm. Let's say if you plot this image, okay, so this image will look like that. This image will look like that. Just a minute, why it's not working? Not sure, just a minute. Okay, this is too thick. Let me change. Okay, let me take the simple pen only. So that's how your image will look like. Okay. Hmm. Now after applying this horizontal, that means this particular filter, what would be the matrix? So how it will multiply, guys? Remember? Any idea? See, it will multiply like that. First of all, what will happen? So this filter, okay, this particular filter, we have to plot on top of the image. Now you can see it is 3 cross 3 matrix. Okay, 1, 2, 3, 1, 2, 3. So it will adjust like that. Okay, let's say this is my first iteration. Okay, and my filter is present there. Now what will happen? It will calculate, okay, all the number. Okay, uh, like number wise multiplication it will do, and it will add all the results all together. That means what will happen? First of all, it will multiply this -1 with 0. So -1 multiply 0. Okay, then plus, then it will multiply -1 with this 0. That means this one will multiply with this one will multiply with this one, and the result you are adding. Now again -1. Okay, then multiply, you are using 0. Again you are doing the plus operation. Okay, then this number you will multiply with this. That means again -1 times 0. Okay, again you are doing the plus operation. Getting my point, guys? Let me know. Yes or no? Okay. Yeah. That's how you have to also do it for the next one. That means now here you will come. That means this particular rows is over. Now you will come to the second rows. Now again you will multiply this 0 with 0. That means 0 multiply 0. Again plus 0 multiply 0. 0 multiply 0. 0. Okay, and so on. So that's how you have to complete for all the number. Then at the end you have to do the calculation, and whatever result actually you will be getting, this should be the result for this particular feature map. Okay. Now you can see there I will be getting a feature map. Now if I do the multiplication with this 3 cross 3 cross matrix, okay, and if I add them all together, so here I will get a number. Now if you calculate all the number, you will see that you will be getting 0 here. Okay, because most of the time you have the 0, and if you multiply 0 with 0, you will be getting 0 here. Okay, then what you have to do, you have to move this particular filters in the next stride. Now see, we have done till here. That means 3 cross 3, 1 2 3. Now we have to start from here. So it will do the right shift operation. Okay, so this my previous filter was there. Now if I do the right shift, it will come here. Okay, just try to imagine this particular image. See, it will every time it will do the right shift operation. Okay, right shift operation, and it is generating the feature maps. Now it will come here, and again it will do the same operation. It will multiply with 0 minus 1 0 minus 1. It will add all the operation. Again you will see that you will be getting 0 here. Okay. Hmm. Oh, sorry. Actually, there was a mistake. It won't be coming here because one step like stride it will do na. So first of all it was there. Let's say first of all it was there. Now if I do the one step, so it will come here. Sorry guys, okay, this was my mistake. Now I think you got it. So one step na. So this was the first column. Now it will come to the second column. Now if it is done, it will go to the next one like that. Okay, that's how it will create a 4 feature map here. Now it will do another one. It has come here. 1 2 3. Now it will start from here. Okay, so you are getting 4 1. So 1 2 3 4. You can see 1 2 3 and 4. Okay, I hope you clear now. Let me know. Now every time you can see it is coming one step. Okay, one step right shift. Got it. Yeah, then it will go to the next. I mean rows. That means it will come here. Let's say if this column is done, then again it will do the downshift operation. That means it will come here. Okay, it will come here, and again it will do the same thing for this particular row. Then once it is done, it will come here. Okay, that's why you can see here also we have 4 1 2 3 and 4. If we take more strides, the feature map size will increase. Now if you are taking more strides, this feature map size will decrease that time. Just try to see why it will decrease. Let's say if I hmm, now see, let's say this is the first stride you are taking. Okay, now instead of taking only one stride, I'm taking two. That means it will skip the next one. Let's say it will skip this one. Now your feature map will come here. That means your filters will come here. Okay, then again you are skipping this one. Again it will come here. Now tell me how many stride you are doing, how many operation you are doing, 4 or 3? Tell me. 4 or 3? If you are skipping 1 3, right, then what would be the feature map size? It would be 3 cross 3 that time. Sorry, 3 cross 3. Got it. So if you taking more stride, that means your feature map will decrease that time. Mm. Yes. So here if you calculate all the numbers, so let's say you will be getting these kinds of metrics here. Let's say 0 0 0 25 to 25 to 25 to 25 to 25 again to 25, because at the end you have some number here. So if you calculate, you will be getting this at the number 225, then 0 0 0 0. Now if you plot this particular image, so you'll be getting this kinds of output. Okay, now you can see it has extracted the horizontal edges from this particular image. Okay, I hope you clear now how things are working. Let me know. Now let's try to understand this thing in a visual representation. Okay, let's try to understand this part in a visual representation. So there is a website called uh, Deep Lizard. Okay, Deep Lizard, I think. So I'm sharing the link in the chat, so you can also open it up. So this is one amazing website they have created. So here you can visualize the convolution operation. Okay, you can see you can visualize convolution operation. So here, the first thing, let's say you can set the data, what kinds of data you want to use. So here you have two kinds of data. One is the MNIST data, another is the fashion MNIST data. So let's select the MNIST data, because as of now we have worked with the handwritten digit. Okay, now you can see this is a 0. Now here you can select different number. Let's say you need 1, you can also select 1. You need, let's say, 6, you can also select 6, but I will set 0 as of now. Okay, yeah. Then you can select different filters. So I think you remember, guys, we use Sobal filter. So Sobal top filter, Sobal bottom filter, Sobal left filters, okay, Sobal right filters. So it is having different filter types. So as of now, let's take this particular filters called left edge filter. Okay, so I'll take this filter. Okay, left edge filter. Let's take this particular filter. Now here you can see this is the matrix you are getting. Window means this is the filter size. Remember, guys, what is the filter size here? 3 cross 3, na? And we have taken this particular left edge filter, and this is how your left edge filter looks like, and this is the number. You can also try with Sobal filter. See, that's how the Sobal filters look like. Left, okay. That means different kinds of number will come at the end. Okay, Zovian link you need. So let me share the Zovian link as well. Yeah. Hmm. Now you can see this is the filter. Now this particular filter will move at the, okay, first stride, that is first iteration on top of the image. Now if you see the number at the first position, it is 0 0 0 0 0. See, you can also hover, you can see the number while this particular pixel value is coming. See, you can also hover, you can try to understand. That means here actually you are doing the operation in this particular matrix, and if you multiply, you will be getting the feature map 0 0. Okay, see, here is the output 0 0. Now you can go to the second step. Okay, now see, this particular circle, sorry, this particular square will move to the one stride. Okay, one actually right shift it will do, and again this is the number, this is the filter, this is the output. Again you can see 0 0 we are getting. Again you can do the next step, you can see the number. Okay, that's how you can do the step operation. Every time you will see the calculation as well as the feature map here. Okay, but it will take lots of time. What you can do, you can click on the play button, you can see the entire visualization. See, that's how your convolution is happening. See, that's how convolution is happening. See, okay, done. Now this is the feature map I got, guys. Now here what is the, I mean, filter I selected, left edge filter we selected. Okay, now you can see most of the time it is extracting the left edge actually features. Okay, vertical features, you can see the red mark. So it is giving more attention here. Okay, it is giving more attention here, and these are the color, actually it is giving less attention. So what happens, we use something called ReLU function. Okay, ReLU activation function in the convolution. So this ReLU, what it will do, it will try to wherever actually you have the 0, it will make it as 0. Wherever you have the uh, I mean point number, it will make it as 1. That means it will more focus on the red part, that means these vertical edges. Yeah, So Sobal X is the same as Sobal left. Yeah, you can consider like that. Okay, this is different kinds of Sobal, let's say, filters. Okay, frankly, so we have learned about Sobal horizontal and vertical. Na, so Sobal is having different filters. Sobal left top is there, bottom is there, left is there, right filter is there. Okay, that's how. Now by doing the convolution we can understand it is it is more giving the attention on the vertical edges. Okay, vertical edges. Are you clear, guys? Let me know. And these are the color you are getting after applying relu. It won't be there, only you will be getting these are the vertical line. Let me know this visualization is clear, all of you. How convolution is happening, let me know. So see, computer vision is completely visualization. Okay, if you can visualize in your mind, everything you can understand. So each layer of the CNN has one filter. Each layer of CNN has one filter. No, whenever we'll be creating the actual CNN architecture, we'll be using multiple filter, Franklin, okay, to extract more complex features. Only one filters won't be working that time. So this is the simple example. That's why I'm using only one filter, okay? But to extract the complex feature, we have to use multiple filters at the end. Okay, and what is the main advantage to use the deep learning here? Because this particular filters number you don't need to decide automatically. This number would be decided by the back propagation. So every time it will calculate the loss, it will do the back propagation, and this feature filters value would be updated so that your model will be learning. Okay, your model will be learning how to extract the complex features, okay, from the entire image. So that is the main advantage to use the deep learning model. Got it? So I think you know how backpropagation works in the artificial neural networks. Okay. Yes. So that's why deep learning is a black box. Okay, we can't see how this particular number is getting generating and all. But in machine learning, we can visualize, right? Hmm. So if everyone is clear so far, please write clear in the chat, all of you. Just give me a confirmation whether you are getting or not. Otherwise, you can ask your question. Let me know, guys. Okay, great. Hmm. So this was for the single channel image. Okay. Now what if you're using color image? Okay, in that case how convolution will happen? So let's try to understand this part as well. So for color image we do the same thing but in every channel. See, so here is the example. So this is my color image RGB. So we have to also take the filter, okay, and as 3 depth, okay, because this will work with the R, this will work with the C. Let me just annotate. This will work with the R, this will work with the G, this will work with the blue, and at the end you have to do the add operation. Okay, after adding, this particular feature map would be created. And always remember, although we are taking three, I think 3 depth, let's say what filters. Okay, although you are using 3 depth filters, but your feature map would be one dimensional. Okay, why? Because at the end you are doing the addition operation. That's why. Okay, now let's see one visualization how the things are working. So there is a medium block. So there is an animation you can see. So it will look like a this kinds of, actually you can see box. Okay, see, that's how your convolution is happening. See, this is the box. That means you can consider this box as your filter. And now see, every time it is doing the stride and multiplying, and here feature map is getting created. Yeah, cubic form you can talk about cube, right? Yeah, 3D cube. Now can you relate, guys, with a single channel as well as the uh, multiple channel, let me know. Can you visualize in your brain how things are working? Hmm, fine. So let's see the next one. Okay, so one thing I want to show you, if I'm using multiple filters, then what will happen? So there is another example I can show you. Let's say I'm using multiple filters. So one filter is for the vertical edge detection, another filter is for the horizontal edge detection. Okay. Now, if you do it, you will be getting two feature map, guys. Always remember, if you're using multiple filters, you will be getting multiple feature maps. Okay. See, here also you are getting one features map. Here also you are getting one feature map. That means two feature map you are getting. Now, if I'm using three actually filters, guys, how many feature map I will get? Tell me. If I'm using three actually what filters, then how many feature map will be getting? Let me know. Three. If I'm using four. If I'm using 100, I'll be getting 100. So whenever we'll be creating the actual CNN architecture, we'll be using multiple filters. Okay, to extract more complex features from the data, because as of now the data we are using, it's a digit data, but going forward we'll be using cat, dogs, human, cars. Okay, these are the complex, let's say, image. That time we need actually I mean more than one filters to extract the information from the image. So sir, feature map is a single channel. Yeah, feature map would be a single channel, but if you're taking multiple filters, that time multiple feature map would be created, but the feature map side would be single channel. Okay, I hope you cleared, Shashwat. So for vertical is there would be another feature map, that for horizontal is there would be another feature map. If there is another filters, okay, there would be another feature map, but the feature map side would be single channel. Why? Because I already explained here, it will do the addition operation every time. Okay, that's it. Hmm. Now the next concept we'll try to understand uh, about the paddings. Why paddings is required? Okay, for this, let's take another image. Hmm. Now I think one issue you saw whenever I'm doing the convolution operation. Okay, my feature map is decreasing, yes or no? Because let's say this is my original image. So what is the size of the original image? 1 2 3 4 5. 1 2 3 4 5. That means it's 5 cross 5. Okay, but after applying these filters, okay, after applying the filter, what is the feature map size? 1 2 3 1 2 3. You can see it has become 3 cross 3. Okay, so can you see I'm losing some information here, because here is my actual image is 5 cross 5, but after applying the filters I'm getting 3 cross 3. So is there any lose? Tell me, guys, is there any pixel lose in my data? Yes or no? Because my image size is getting decreased, huh? Now if you apply another filter on top of it, again you will see that this image would be more, I mean, small. Okay, that's how. So to prevent this issue, we use something called paddings. Okay, so how paddings works, so let me show you another image. So here what I can show. Hmm. So we add some 0 pixel, okay, like that. This is called padding. Now you can see the size is same. Okay. See. Now you can ask me why we have to add. We have to add in the original image. Okay. If you apply on top of the original image, then your size will remain same. See, this is my original image 5 cross 5. Now after adding this padding, okay, you can see 0 0 0. So now what is the size? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Okay. Now it will become 7 cross 7. You can see it's 7 cross 7. Now if you apply this feature map, you will see that if you calculate all the stride, you will see that it will become 5 cross 5 that time. 5 cross 5 that time. Okay. Now you can see this is and this is are same. Okay. This image and this image are same size right now. Okay. Now in PyTorch and TensorFlow, there is a parameter called padding. Padding, if it is valid, that means you don't need to apply. You are not applying any kinds of padding. And if padding is equal to same, okay, that means you want to apply the padding. So whenever we'll see the practical, that time I'll show you. Okay. See, it's not always necessary to add the padding, but sometimes you can also add if you're having a small size image that time. Okay. It's not necessary. It's a hyperparameter tuning you can talk about. Okay. If you're creating the custom architecture, that time you can tweak the parameter. Either you can set the valid, that means you want to add the sorry, you don't want to add the paddings, and if it is same, that means you want to add the paddings. Okay, that's all. Okay. Yeah. Only to increase the size of the feature map, we add paddings. Yes, you are right, Shashwat. We want to keep the same size, okay, as per our input image. That is the use of the paddings. Okay. After doing the convolution operation, my feature map size won't be decreased. Okay. That is what I want. Now let's try to understand the stride. What is stride? Stride. Stride, I think you already know what is stride exactly. Stride means the step actually you are taking. Na? So if I show you this uh, example, see, this is the padding example you can see. Okay. Now this is the stride concept. See, stride means the movement you are doing na, every time. This is called stride. See, the movement, this movement. Okay. So after it is doing actually one step movement. If it is true, that means it will skip two. If it is true, that means it will skip one pixel. Okay, like that. Step taken at a time. Yes, you are right. Okay. Yeah. So you can see the visualization. By seeing that, you can understand. Okay, what is stride? So this is what your stride is. Okay. Now here is the matrix one. You can see all the visualization is there. You can simply open it up. You can try to understand. Okay. Hmm. So let me know so far till this stride everything is clear, guys. All of you. If it is clear, we'll be moving to the next topic, which is nothing but pooling. Now let's go to the next topic called pooling. So what is the use of pooling? Let's try to understand. Let's say there is a image. So here you can see, here we are doing the convolution operation. And can anybody tell me here we are using single filter or multiple filter? Let me know. In this example, we are using single filter or multiple filter. By seeing the architecture, you can let me know. Multiple filter, na? You can see filter 1 and filter 2. Then that's why we are getting multiple feature map. Okay. Now one thing you can see, whenever uh, we are not using pooling layer, so our computation is increasing. Okay, that means our here I can write. So the first issue will be having memory issue. Okay, memory issue. Okay, if you're not using pooling layer, how? Let's try to understand. Okay, how we are getting this particular memory issue. So mhm. So let's say if my image size is, okay, let's say if my image size is uh 226 times 226. Okay, and with that I'm using, okay, uh just a minute. Huh. So with that, let's say you are using uh 36 filter or 32 filter. Let's say this filter you are using 32 filter. Now if you calculate the number, okay, if you calculate the number, or let's say here I can write you are using 100 filters. Okay, 100 filters. Now if you calculate the number, you will be getting a big value here. Yes or no? You'll be getting a big value. And if I'm using, let's say, 32-bit, okay, 32-bit memory. So if you calculate almost only one, let's say, data, you will be end up with 90 megabyte. Okay, 90 megabyte storage in your memory. Okay. Now let's try to consider for all the pixel you have. So it will cross more than 2 GB. More than 2 GB it will cross. Because at the end it's a matrix number. Okay. It's a matrix multiplication you are doing, and you know that you will be ending up with high, I mean very high number here. Okay. And this particular number will take more space in the memory. So this is the main problem. Okay. That's why we use the pooling layer. Okay. So in the pooling layer, what we can do, we can reduce the number of actually pixel. Okay. How? 2 GB, it is not in the GPU. Wherever you are executing, it will take in the RAM. Okay, mostly in the RAM, random access memory, because all the data at the very first time your computer will load in the memory RAM. Okay, then it will pass to the computation. Yeah, that's why training image data is not an easy task. Okay, but because here we are doing so many computation. Now let's try to understand how pooling will help you in that case. Okay, so let's say this is one feature map you got. So let's say this is one feature map you got. Let's say this is my feature map. After doing the filter multiplication, I got the feature map. And you need to always remember, we use pooling layer after the CNN layer. After convolutional layer, CNV layer, we'll be using pooling layer. Okay, always remember, guys. So first of all, we'll be using conv layer. Then we'll be using ReLU. Then we'll be using pooling. Okay, this is the flow of creating CNN architecture. Okay, first of all, con, then ReLU, then pooling. So let's say we have applied the con layer and we got the feature map. Okay, FM feature map. Now here we have to define the pooling size. So pooling is nothing but it's a matrix at the end. Okay, again it's a matrix. So you can define the size. Let's say I want 2 cross 2. This is the matrix I want. Okay, for the pooling. So what will happen? One pooling would be created. So here, like that, it will create a matrix like that. And this matrix, it will take the dominant number. Now, can anybody tell me in between this four number, what is the dominant number? You can see. Let me know. What is the more dominant number in between this four number you have in this particular 2 cross 2? Normalization is a different technique. Okay, it's not. Yeah, 5. 5 is a dominant number. That means it will create a matrix like that. So at the first time 5 will come. Okay. Now this pooling will move here. Now in this matrix, what is the more dominant number? Tell me. What is the more dominant number? 3. 3 will come. Now this pooling will come here. Here 7. And here 4. Okay. So this would be your feature map. So that's how you can see you have reduced the computation. Okay, you have reduced the computation. Now previously you have 1 2 3 4 1 2 3 4 4 cross 4 actually matrix. Now after adding pooling you have done it to 2 cross 2. That means you have reduced half of the computation. Okay, and you are only focusing on the dominant feature. Okay, dominant feature. Now let's try to understand in a visual representation why dominant feature. Okay, because what happens, let's say, no, some information might be lost, but I need the dominant feature at the end. See, if I want to understand the shape, I need the dominant, let's say, edges only. So let me show you one example. By seeing the example, this understanding would be more clear. So what I will do, I will again use that deep lizard website. Okay, so this is another link. So this will give you the max pooling visualization. No, there won't be info loss in the pooling. Why? Because I'll let you know. Okay, now just open this website, everyone. I shared in the chat. Now again, let's select the data. I will be using MNIST data. Let's see, select the 0 only. And filters, I'll be using these filters. So filter height, filter width, horizontal stride, vertical stride. Okay. By default, I will take everything. Okay. Now see what will happen if I do the play operation. Now, did you get it? Why? Okay. Why? There won't be any kinds of information loss. Because you can see in this image, there are so many background. There are so many background also, you can see. And if I want to understand this 0, okay, I need the dominant actually number only. See, this is the dominant number it is only getting. Tell me guys, got it? So I have reduced this image uh, hub, right? But still the information is there. Okay. And that's how we can reduce the computation. Okay. See, everything is visualization. Just try to visualize in your brain. That's it. So that's why pooling is required. You will see that in every CNN architecture, people are using pooling. Okay. Because of that. Now there are some advantage also for the pooling because it will take the dominant feature. So let me show you one image example. So let's say this is the example you can see. Okay, sorry, just a minute. What happened? Okay, I can again paste that image. So see guys, this is one example. So the goal of PF fooling and padding seems to be the opposite. Pooling and padding. Yeah, see, padding, that's why I told you, na. So it's a hyperparameter tuning. Sometimes Let's say padding will work better in some images. Sometimes this pulling will work, okay, in some images. Okay, that's how. Okay, it depends upon the image complexity. If you are having very simple shape image, that time you can use it. Okay, if you're having complex, that time you have to use that. Now see, this is the image. Now after applying max pulling, see there are some pulling also, like we have max pulling, we have mean pulling, okay, we have average pulling, and so on. Okay, that's how different pullings are there. But most of the time people use max pulling because of that dominant number. Okay, mean pulling means you will be using the minimum number. Average pulling means you will be taking the average number. Okay, that's how it works at the end. Fine. But most of the time I saw that people are using max pulling. Now see, this is the max pulling example. Now you can see this is the feature map. After applying the pulling, you are getting this one. Now can you see it is getting more dominant edges? You can see the more dominant edges. Can you observe? Yes or no? So this one is like little bit, I can say, I mean, very thick, but this one is not actually that. It is getting more dominant. Yes, that means your model can understand better. Okay, after applying the pooling, this is the shape of the image. Okay. Hmm. Yeah. So let me know, all of you. So you have shared one image with me, Franklin. Let me open it up. What is the image? So this is the example of pooling, okay, different pooling, like original image. This is the result of average pooling. This is the average of max pooling. This is the average of pin pooling. Okay, you can see. Was thinking that padding works during when extracting the feature spell. Pooling is the maximize the dominant features. Can you please clarify? See, padding means you don't want to let's say decrease the feature map. Okay, that time you can use padding. And pulling, you want to get the dominant features. Okay, that is the difference. Dominant means you want to highlight that particular image more. Okay, you can see here it is doing the more highlight operation. And with what you are doing, you are also reducing the computation power, because only you are taking the dominant number. Okay, not the less number. Okay, I mean small number. So this is the foundation, guys. Okay, now next class we'll try to do the practical. We'll try to create our custom CNN architecture, and with the help of that we'll try to train one image classification model. Okay, so tell me, guys, so far did you understand this concept, this convolutional layer, padding, pooling? Okay, stride. In mean pooling, it will go for the non-dominant features. Yes, you are correct, Shashwat. It will take the minimum number at that time. Yeah, so for today, actually, this is the agenda. Okay, I'm not going to take the practical because after that I have another session. Uh, Agentic AI. I think you remember, guys, from today, this Agentic AI course is starting. So the class would be 9 p.m. IST. Okay. So today is the first session, and if you are interested learning this Agentic AI, you can join this particular session also. Okay, if you want. No, first of all, we'll do the introductory because today is the first session. We'll do the introduction and introductory. Then from the next class, we'll move to the practical part of the agentics AI. We'll implement different agents with different frameworks. Okay. Hmm. So this CNN concept is clear, all of you, let me know, because now we will be entering into the actual computer vision part. Okay, like classification, object detection, segmentation, then tracking, OCR. We'll try to do that. So the more interest you will be getting whenever we'll do the practical. Okay, we'll try to implement different solution. That time you'll be getting more interest. In Jovian link, we do have to create an account to view the link. Yes, first of all, you have to create one account with your Google. Then you will be able to see the content. Vivash. Yeah, and please go through whatever material I shared with you guys. Please try to go through and try to understand. Okay, try to visualize in your brain. If you can visualize, everything would be clear. Okay, computer vision is all about visualization. That's it. Yeah, it's all in the mind at the end. Yeah, but in case NLP, we can't visualize. Okay, this is the issue. NLP, it's not. I mean, that much easy to visualize in the brain, because here we work with the higher dimensional data. But computer vision, we can visualize. Okay. So fine, guys. I think we are done. So this was the topic for today's lecture, and tomorrow we'll start with our first uh, first actually practical. We'll try to create our first architecture called CNN architecture, and we'll try to train a basics model. Okay, then we'll try to move on the transfer learning. That means we'll be using pre-train architecture. Okay, this is the agenda. And please join the agentic AI if you are interested, guys. So it will give you more knowledge on the generative AI, because currently agentic AI is trending a lot. People are using AI agents in their development, and if you want to upskill, definitely you have to know that. Okay, so thank you guys for joining the session. Bye everyone. uh Bye all of you. Thank you. Thank you all of you.